Hello Ninja Warriors. So today's session is going to be the very first session for the chapter functions. Now, do I need to tell you that functions is a basic building block for your calculus, which is a complete unit in class 12th, which occupies almost 40% of your weightage of your JEE main and be it your basically school examination. Okay, so I hope that you know that calculus consists of limits, continuity, differentiability, differentiation, then application of derivatives, integration. In integration we have indefinite and definite, then application of derivative along with differential equations, right? So many chapters in single unit, that is calculus. Now you won't be able to master calculus if you skip functions or if your functions stay weak. So it is very important for you all to make your functions chapter rock solid so that when we hit calculus, when we start calculus in class 12th, we are pro in functions. Okay, all right. On this note, we are going to start today's session, but before that, let me just keep the chats open. Okay, and let me also know whether I'm audible and visible. Meanwhile, one thing is that you need to like the session right away. Okay, all right, like the session right away, everybody. So I can see already people are joining in. Okay, and if you will ask me that, ma'am, whether we can attend this session, I am in class 11th or I am a 2027 aspirant, go for it. Trust me, this session is dedicated to 2026 aspirant, but trust me, this particular session is also for 2027 aspirant. Class 11th and 12th must watch session. Okay, everybody. Yes, hi Rohanit, how are you? Hi Gokul, hi Aruneshwar. Make sure you hit that like button. Okay, everybody. Yes. So we are going to start it off with functions, but I don't want to start off with functions. Rather, I want to talk about one example, which is my favorite example, which is a juicer example. Okay, because I think almost everyone will have juicer or mixer in their home, almost. Okay, so we have a juicer, and you know what, this juicer will work only when you give input in that juicer. Okay, so now I am putting oranges in this juicer over here. You can clearly see oranges. If you put in that juicer, you operate it, you switch on it, you switch it on, you will realize that you are getting an orange juice. Yes, you are getting an orange juice. And you know what, if I change the input, tell me, if instead of oranges I put mangoes in this juicer, what would I get? I get mango juice, right? That means, see, there are three things happening over here. Three things which I can see that it is registering in my brain. There is one machine over here, okay, which we are going to call it as a function. Then there is an input. Okay, over here input is mango or oranges, and then there is an output also. Along with that, one very obvious fact is that the moment I change the input, my output is also getting changed. Right or wrong? The moment I change the input, my output is also getting changed. Okay. All right. Now, if I go further and let's talk about spinach. Okay. So, suppose you put spinach in this juicer, you will get spinach juice. Any more any suggestions? Do you want me to talk about any favorite food of yours or any favorite fruit such as strawberry, watermelon? What is your favorite fruit, by the way? Comment below. I just want to know that yes, which one is your favorite fruit? Yes. Which one is your favorite fruit? Okay. So here we can see that if you put strawberries, you will get strawberry juice. But if you put stones in this juicer, your juicer will break. So many things we are able to understand. First of all, that output, three things. See, input, okay, input, then machine, then output, right? Three things. And output is dependent upon input. That is one thing we have observed. Also, one more thing, that if we put random input which is not applicable, which is not good for this machine, suppose stones. Stones are not good for this machine, right? So what you're going to get is your machine will break. Okay, all right. So here we will call this as so what will happen over here? We have an independent variable, okay? So all the things like mangoes, like oranges, like strawberries, spinach are nothing but independent variable, okay? Right? Now this is your function, which is your juicer, and this is your dependent variable. Why this is dependent? Because this output is depending upon what input are you giving. Right or wrong? Yes. Are you getting this concept, everybody? Yes. So now I have something for you, which is this. And can you see? Oops. What happened? Why is it not happening? Yes. So can you see, this is your function, this is your input, and this is your output, okay? Let me just tell you about this. Suppose input is your x, okay? And then you are giving in function f of x. So this is your function f, okay, f. And this is nothing but f of x is equals to y. Y is your output, okay? X is input, f is function, and y is output, which is nothing but f of x. This is the whole concept of, basic concept of functions, okay? Everybody got it? Got the slight idea what the function is? Okay. Now we will get back to function, but before that I would like to tell you brief introduction about myself, okay? And you can see on your screen that my name is Namrata, and I have over more than 10 years of teaching experience in both online and offline, famous for my amazing ninja techniques that you are going to see in upcoming sessions in future super soon. Along with that, we are running Vedantu learning centers across India, okay? So you can clearly see that there is a big difference in Vedantu Learning Center and your other coaching centers, right? So we provide 100% guaranteed improvement. That means if you don't feel that I am getting improved, if your rank is not getting improved, then we will refund your money. So locate the center right away. You can see our offline centers are in your city. You can locate it. You can see Tamil Nadu, Telangana, Delhi, Andhra, Punjab, Maharashtra, and so on. And can you see, hurry, the seats are filling fast, limited seats are there, because personal attention is the key. So just register yourself and do this, okay? Everybody coming back to functions? Coming back to functions, okay, let's start. So now function basic definition, so you have seen. Now how many of you were there in my relations session? How many of you were there in my relations session? How many of you were there? In my relations session, I told you that what is a relation. Now function as a relation. Another definition of function I will teach you. Okay, this is another definition which is in context with relation. Okay. So if you see this definition, you will realize that function is a relation defined from set A to set B. Function is a relation defined from set A to set B, such that each and every element of set A is uniquely related to an element of set B. Understand? First of all, function is nothing but a relation, okay? But this relation is having some rules. Let's try to understand those rules. Number one rules is, so again two sets are there. You can see this is set A and then this is set B. This is again set A, this is set B. This is function from A to B. This is also function from A to B. Function is nothing but a type of a relation only. Okay? Alright, but in here, The very first rule is each and every element of set A is related to, okay? That means in set A, all elements should be occupied. All elements should be occupied. All elements should be occupied. Okay, the second rule for a relation to be a function, listen to me carefully. Now, the second rule for a relation to be a function will be that one input cannot have two output. This is not allowed. Okay, this is not allowed. Can you see? This is not a function, not allowed. Okay, all right. That means single input and two output is not allowed. And input means set number A and output means set number B. Okay. So the mapping diagram should not look like this, that one input, one element is having two mapping. No, no, no. Rather than that, is it allowed, by the way, two input, basically input number 1 and input number 2 can share the same output. This is allowed. Okay, this is allowed. Okay, if this is the case, then the relation is relation but not a function. Okay, everybody getting it? Now let's understand what Ninja Ma'am is trying to tell you using the mapping diagram. Okay, so over here, if you can see that, yes. So let us understand whether this mapping diagram is a relation. Definitely this is a relation, but whether this relation is a function, let's check. Okay, so we'll check. The very first thing is set A, all elements should be occupied. Let's check. So set A, all elements 1, 2, 3, all are actually mapped. Nobody is free from in set A. So that means this first condition is getting fulfilled. Okay, ma'am. The second condition is one input should not have two outputs. So clearly this input is having single output, this input is having single output, this input is having single output. That means condition number 2 is also getting satisfied. So this is a function. Okay. Now let me come back to this. Okay. So clearly the condition number 1, which is set A, all elements are occupied, which is there. Condition number 1 is getting fulfilled. But can you see one input and two output? That means condition number 2 is not getting satisfied. So this is not at all a function. Everybody getting it? Yes? Okay. All righty. Okay. Now just answer a couple of questions, right? Let's see. Okay, let's see. Now just tell me whether this is a function or not, although it is written already over here, whether it is a function or not. So I'll be like, okay, let me check. Now set A, all the elements should be occupied. Okay, ma'am, A is occupied, B is occupied, C is occupied. First condition is getting fulfilled. Okay, all right. Now, if I see one input, is there any case getting found where one input is having two output? No. B is having 1, C is having 1 image only. So this is definitely a function. Okay, let's talk about this. Clearly this is not a function because one input and two output. No, no, no. So not a function. And here, can you see this C over here is left out? That is why condition 1 is not getting fulfilled. That set A, all elements should be occupied. Now, then why is C left out? C should not be left out in the first set A. Okay, so this is again not a function. Okay, now let us recall this right away, which is what is domain, what is range, what is codomain, although we have seen this in my previous lecture, relation. Okay, what is the domain? Can anybody tell me? Domain is nothing but all the values of set A which are occupied. Okay, all right. So now you'll be like, ma'am, in functions, so everything is occupied now. In set A, if you are saying that the given relation is a function, so set A, everything will be occupied. So can I say that in case of function, domain is nothing but complete set A? Yes. Okay, so domain means set A, B, C here, A, B, C, right? So domain over here is nothing but A, comma, B, comma, C. Okay, all right. Yes, chalo. Let's talk about range. Okay, let's talk about range. Range means all the values that F takes. Okay, all the values F takes. So range means what? That, so if I talk about this, range means all the values of set B which are occupied. Okay, so in here range 1, 2 and 4 will be the range. 1, 2 and 4. Okay, 3 will not be in my range because 3 is not occupied, no? Okay, now if I talk about codomain, so codomain mein it's very easy. Complete set B, the second set, is your codomain. So complete set B. So in this case, 1, 2, 3, 4, all the elements, whether connected or not, this is going to be your range. Okay, all right. How many of you are getting it? Okay, clear? Acha. Now one more thing. So I think functions as a machine you have learnt. Functions as a relation, right? Like a Venn diagram, mapping diagram, you know. Now function as a graph. If a graph is given, like proper graph x and y axis, will you be able to tell me whether the given graph is function or not? So for that, Ninja Ma'am has a special solution. This is vertical line test. Okay, vertical line test. What does this vertical line test suggest? Vertical line test says, suppose a graph is given, suppose this is y is equals to x square, correct? And this is the graph if you can see. Now what you need to do is, you need to draw vertical line, okay? And that parallel vertical line, okay? So draw vertical line. Can you see this is a vertical line? Then this is a vertical line, okay? This is a vertical line. This is a vertical line. So many vertical lines draw. Okay, and then you will realize this is nothing but VLT, vertical line test. VLT, 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 VLT. Okay? All right. So whenever you draw a vertical line and this vertical line is intersecting the graph at single point. Can you see? This vertical line is intersecting the graph at single point, right? What does that mean? That this is a function. Yes, this is a function. So can you see this is a function? Now here same thing if I do, can you see that this time y square plus x square is equals to 9. This is a circle, equation of a circle. Circle looks like this. And if you draw a vertical line, you will realize that this vertical line intersect the graph at 2 points, okay? Can you see here also and here also? That means more than 1 point. So if more than 1 point, that means this is not a function. This is not a function, okay? Acha. Yes. Hi Pratyush Gupta, late? Are you late? Chalo. Now one thing I would like to ask you, that why is it happening? I mean, okay, ma'am told you that if you draw, if a graph is given to you, draw a vertical line. If it is intersecting at single point, it is a function. And if it is intersecting at more than 1 point, it is not a function. But why? Why on the earth? Why is it even happening? Can you tell me? Why is it happening? What's the reason? Let me tell you. See, let me tell you. Over here, see, if you put x is equals to 1, if you put x is equals to 1, you are actually getting y is equals to 1. So 1 input, 1 output. So x is equals to 1, y is equals to 1. X is equals to 2, y is equals to 4. Can you see? You have drawn a mapping diagram. So that means 1 input, 1 output. But what is happening over here? Tell me. So this is your input set x, this is your y. If you put x is equals to 1, if you put x is equals to 1, what will happen? X is equals to 1. So it will be y square plus 1 is equals to 9. Y square is equals to 8. Y is nothing but plus minus 2 root 2. So at x equals to 1, you are getting two values, plus root 2 minus root 2. Okay, so can you see one input, dual output, double output, and here the same thing is happening over here. If you put x is equals to 1, suppose this point is x is equals to 1, and it will give you two values. This is plus 2 root 2 and this is minus 2 root 2 graphically, right? So the same logic is simplified for you people. You don't have to put the value and check it. Just draw a vertical line and check whether this is a function or not. Did you understood the reason? Ma'am, if it is not a function, what is it? That is circle. Is there anything else? No. Nothing else. Then it's a simple equation involving two variables, but it is not a function. Okay. Now this simple equation involving two variables is a function. Okay. Are you getting my point? Yes. Okay. All right. Let's talk about some more. Y square is equals to x. Is this a function? Let's see. Y square is equals to x is a rightward facing parabola, and if you can check with the vertical line test, you can see that this is not a function. Y is equals to x cube. Y is equals to x cube. Can you see that this is the graph, and if you draw the vertical line VLT anywhere, you will realize single point. Okay, single point means this is a function. Okay, are you understanding it now? Okay. How many of you have understood this? Okay. Now let's talk about types of functions. Types of functions. Okay. Can anybody tell me what are the types? Huh? Like you must have encountered some functions like logarithm, polynomial. Just type everything. JEE aspirant is saying 1 to 1, many to 1 into. No. This is not a type of function. This is what you are calling as a classification of a function. I am just talking about the types of function which are available, which you can use. One function is nothing but the classification. Like cubic function are one function or many one function. Okay. No, I'm not talking about. Again, Ronit, no. Into onto many one are not functions, right? Into onto many one is a classification. See, I am just asking you that name a girl in your class. And you are replying me, ma'am, red color, red color dress. So you are telling me the features of the function. I am talking about the name of the function. Okay. So I can see, again, injective, bijective is not a function. It is a type of a function. Okay. Yes. So I have now I have started getting the names. Modulus function, yes. Greatest integer function. Fractional part, logarithm, exponent, signum. Okay. Yes. Constant, polynomial, nearest integer. Okay. All right. So types of function. Okay. So in whole class 12th, you will encounter so many functions, right? Like logarithm function, exponential function, polynomial function, rational function, then greatest integer function, signum function, fractional part of function, okay? But right now you only know the names. But you have to deal with those functions in the complete calculus. You have to find out integration of log. You have to find out derivative of log. So you have to have a clear understanding of all the functions. Okay. So in this segment, what we are going to do is we are going to talk about the types of functions. For example, polynomial function. Let's say polynomial. So we'll be doing the post-mortem detailed report of every function. What will it include? Now, post-mortem report means that we are going to talk about the graph of the function, the domain of the function, the range of the function, right? These three things I think are enough to give any detail about that particular function. Okay, all right, chalo. Let's start with the polynomial function. How does a polynomial function look like? So, can you see polynomial function is nothing but an x raised to power n plus an minus 1 x raised to power n minus 1 gradually. So, I'll start with the highest degree. Gradually, I will decrease the power of x. This is a polynomial function, okay? Polynomial function means what? It can have so many things. Constant polynomial. Then it can have linear, quadratic, cubic, biquadratic and so on. Okay? All right. So now I am going to talk about this first thing, which is constant function, okay? So f of x is equals to a naught. Suppose everything is 0 last, a naught, okay, a naught. Or you can say that f of x is equals to c. This is the function, right? The graph of this function, can anybody tell me? The graph of this function will look like this. This is your x-axis, this is your y-axis, and now we are having, okay, this. So this is nothing but f of x is equals to c. Now, can anybody tell me what is the domain of this particular function? Domain means what all input you can give to this. What all input you can give to this. Ronit is saying surgery of functions. Yes, surgery, and then post-mortem report we will share now. Yes, so domain of this function, that means what all values you can put inside this. So in the place of x, you can put anything. So domain means x belongs to all real values. Now, what is a domain? Tell me, what should be the definition of domain? So domain is nothing. See, the definition of domain is that all the values of x for which your function is defined. Okay, so if I just go back and talk about it. Okay, if I go back and talk about it. So domain means, so suppose this f of x is equals to 1 upon x. Okay, so now if somebody is asking me what is the domain of this function, so domain is set of all those values of x for which the function is defined. Okay, so now you'll be like, okay, so you'll be putting values, put x is equals to 1, 2, 3. Don't do that. Just think about what all values of x will be there, if at all if there any values are available. If I put over here, I will get not defined. So clearly x is equals to 0 will make the function not defined. That means domain will not have x is equals to 0. Rest everything is allowed. So x belongs to R. Everything you can put in place of x except 0. This is your domain. Okay. Getting it? Yes. So this is how your domain is. So here, just tell me, for example, f of x is equals to 3. What is domain? Domain can be anything, all real values in this case, all real values. What is range? Now let's talk about range. Can anybody tell me what is the range of this function? So range means the output values. So range is all about, you have to now apply your brains. That, okay, now you have your domain, that means all values you can put in place of x. But what will be the output? Output is always 3. no matter what value of x you will put, what output are you going to get? 3 always. Okay, so graph is also saying, so range is nothing but x is equals to 3. Or you can, yes, that's it. This is your range. Only 3 you will get as an output, nothing else. Okay. All right, getting it? All right, so this is your constant function. Now let's talk about something which is linear function. Linear function is, suppose f of x is equals to ax plus b, where a cannot be 0. Okay, and b, a and b both are real numbers where a cannot be 0. Why a cannot be 0? Can anybody tell me why a is not 0? Why a is not 0? A is not 0 because if a becomes 0, then it will not be a linear polynomial. No? Linear polynomial. Okay, I want linear. So a can never be 0, everybody. Okay, so now if I draw the graph and it will become a straight line, ax plus b. And a straight line looks like this roughly. So what will be the domain? So you'll be like, acha, what all values will be there which I can put in place of x? Think differently. Is there any value if I put over here and I will get not defined? So I don't find any value. I think you can put anything. Again, domain will be x belongs to all real values. And what is range? Can you just look at the graph and tell me what is the range in this case? So range in this case is x belongs to R. See, can you see all the values you are getting in place of y? Y is fx, right? So you want that what all values of y are we getting? See, y is becoming 0, 1, 2, 3, 4. Can you see? The graph has occupied complete y-axis. The graph has occupied complete y-axis. Okay. Now if I talk about, now there is this function which is an identity function, okay. Remember that identity function is nothing but y is equals to ax plus b, remember, where b is 0 and a is 1. So this is nothing but y is equals to x or f of x is equals to x. The graph looks like this. Obviously, you must have seen this. Domain of this function is x belongs to all real and range of this function anybody. Range is again x belongs to all real because y is equals to x. Whatever x is same as y only. Okay, everybody? Yes, getting it? Okay. Now we have a quadratic polynomial. Quadratic polynomial. Everybody getting it, understanding it? Huh? This is so important. Quadratic polynomial are of two categories, ax square plus bx plus c is equals to fx. Okay. Ax square plus bx plus c is equals to f of x is equals to y. Here your leading coefficient is positive. That is why your graph of quadratic polynomial is upward facing parabola. Here leading coefficient is less than 0. That is why your graph is downward facing parabola. Ma'am, difference between identity and constant function. Come on. Hema, what are you even asking? Both are completely different functions. Huh? Identity function is y is equals to x. Linear identity function is having degree 1. The graph is completely different. And constant function is y is equals to 3. That is a constant function degree 0. Yes? Okay. Now, can anybody tell me that what do we call this point? Can anybody tell me? This point. This point. So, this point is a vertex. Okay. So, the x coordinate of this point is minus b by 2a. And here also, this is also vertex. X coordinate is minus b by 2a. Okay. Now if I talk about y coordinate of vertex, so y coordinate of vertex is minus d upon 4a. And here y coordinate will be minus, how many of you know this already, huh? Minus d upon 4a. Okay. So what does that mean? So first of all tell me. What is the domain, huh? So you'll be like, okay, domain ax square plus bx plus c, where a is not equals to 0 and b comma a comma b comma c belongs to real. So first of all, domain of both the functions. Let me just talk about domain. Domain of all the functions. X belongs to all real. And what about range? So range will be what? In this particular case, can you see that the graph is having some minimum value and it is going all the way up to infinity? Okay. Hi, thank you, Shakti. Thank you so much. Keep studying, keep rocking. So over here, can you see the minimum value? What is the minimum value? Minus d by 4a. Okay, and what is the maximum value? It is going all the way up to infinity. This is y belongs to. And over here, y belongs to, now can you see the maximum value is this, minimum value is this, so minus infinity to minus d upon 4a. Okay. Yes? Everybody? Give me a big thumbs up. Give me a big thumbs up if you are able to understand. Okay. See, this is slightly different from the row series, obviously. Now we have another function which is y is equals to x square. The graph of y is equals to x square looks like this, you can see. Okay. Now one very important thing, point to be noted, it is very, very important. Okay. It is very, very important. If n is even, okay, if n is even, that means you have quadratic polynomial, you have power 4 polynomial, power 6 polynomial, okay. That means, so in that case, always remember that your range will be always a part of all real values. Can you see? Let me go back, huh? Let me go back. This is what you can call it as a even degree polynomial, right? Can you see what is the range? The range can never be minus infinity to plus infinity. No. The range will always be some value to infinity or minus infinity to some value. That means this will always be a subset of minus infinity to infinity. Some less value will be there. Okay. It will not cover all real minus infinity to plus infinity if it is an even polynomial. Okay, this is very, very important. Now again, if your n is odd, that means if you're going to talk about linear polynomial, if you're going to talk about cubic polynomial, power 5, then the range will always be all real. That means minus infinity to plus infinity, because can you see the graph? The graph covers the complete y-axis, top to bottom. Okay, this is so important. So what I am trying to tell you is odd degree polynomial. The moment you will see a cubic polynomial or power 5 polynomial and anybody is asking you what is the range of it, no need to calculate. Direct result you have. Just take minus infinity to infinity and move on. Okay. Alrighty, clear? Yes. Chalo, let's do one thing. I have 3 questions for you. Let's see how many of you are able to get this answer correct. You need to first of all find the domain and range of these 3 questions. Okay? How ready are you? Quickly tell me. All right, let's see. The very first is f of x is equals to sine square x plus cos square x. So first of all, x. So if I talk about sin x is also accept every input. X belongs to all real. And cos x also accept every input, right? Tan x, by the way, tan x doesn't accept pi by 2, 3 pi by 2. That is odd pi by 2. In tan x, we cannot write that domain is odd pi by 2. But in sin x and cos x, there is no such restriction. So first of all, domain is x belongs to R. Okay. And what about range? So clearly sin square x plus cos square x becomes 1. So fx is equals to 1. This is a constant function. So x belongs to, no need to write belongs to, also equals to only 1. Now what is this? This is a linear polynomial. Okay, so we know that domain is x belongs to R and range, sorry, not x, na, y. Did I write x belongs to anywhere? No, by mistake. Sorry, range is always y belongs to, What am I doing? Silly mistake. So, y belong. Nobody is telling me also, y is equals to 3. Yeah, better. Now I told you that odd polynomial function is having a range y belongs to R. Everybody? Okay. Now this is a quadratic. Again, domain is x belongs to R. Now range. For range, I told you. If, let's go back. First of all, just tell me that x square plus 3x plus 1 is which particular case of quadratic polynomial, this or this? So clearly leading coefficient greater than 0, that means this case. So your domain is x belongs to R, but range is minus d upon 4a to infinity. Direct formula I can use because we have studied right away. So minus d. Discriminant, can you calculate? Discriminant. Discriminant is nothing but b square minus 4ac. So 3 3s are 9 minus 4. 5. Correct? Okay, this is your 5. So now y belongs to minus d. So minus d is minus 5 upon 4a, comma infinity. Yes? Nobody has given me this answer of this. Why? What happened? Correct or not? Clear? Chalo, time for some another question, another function. So types of function mein the only function we have mastered is polynomial function. Now is the time we should go and talk about rational function. Okay? Rational function. Okay, Mithul is asking a doubt. Why range belongs to codomain but not equal to codomain? No, who told you? Range can be equal to codomain. Range can be subset of codomain, and the same concept we are going to study while studying classification of function, that is 1, many one, into, onto function. There will be a session, most probably the next, like not the next one, a session after that. So that we are going to study. Now rational function. What is a rational function? Can anybody tell me? What is a rational? Do you remember that definition of a rational number? A rational number is a number which can be represented in p by q form where q cannot be 0. Remember? And p and q will be real numbers. Okay, P and Q are integers basically. Remember that definition. Now rational function में a function h of x is equals to fx upon gx, where fx and gx are polynomial function of x. Okay. Now in case of rational function, see fx is also a polynomial, and we know that polynomial functions are very good functions, right? They have domain all real values. For all polynomial function, quadratic, cubic, tell me, you have domain x belongs to minus infinity to plus infinity, right? But in here, what is happening? Fx upon gx. Gx is lying in the denominator. And I told you already that denominator can never be 0. So gx can never be 0. Just keep that in mind. Okay, all right. So are we ready for rational function right away, right here, right now? Okay, all right. So now the question in the rational function is this. Can you see? This is linear by linear. Category. What is the category? Linear by linear. Linear by linear. Okay, this is the category. Okay, so f of x is equals to x plus 1 upon 3x minus 5. Okay, now to calculate domain, so here we'll be calculating domain. In such cases, the calculation of domain will be just that denominator can never be 0. That's it. You will accept everything except denominator becoming 0. So 3x minus 5 cannot be 0. So x cannot be equals to 5 by 3. So now your domain finally is equals to all real values except 5 by 3. Okay? Got it? Everybody? Okay. Now one interesting thing, now let's talk about range. Calculation of range is always slightly difficult than calculating domain. Okay. So understand this and keep this in mind, that calculation of domain will require more effort, more brain, more trick, okay, and more steps. So how to calculate range? So first of all, what we will do is y is equals to x plus 1 upon 3x minus 1. This is your function, okay, right? Calculation of range means what? You want values of y, right or wrong? You want values of y, okay, ma'am. So now what you need to do is you need to cross multiply, and right now what is the current situation of this function? Value of y is completely given in terms of x. Yes or no? Right now y is on the left hand side, and on right hand side we have an expression involving x. Okay, right? But to calculate range we need to cross multiply and calculate the value of x in terms of y. Yes, I'll show you. Cross multiply. 3xy minus 5y is equals to x plus 1. It is very easy, right? So now 3xy minus x is equals to 5y plus 1. So what I am doing is I am keeping all the terms related to x on one side. So this and this I am keeping on the left hand side. Rest everything will be on the right hand side. Okay. Now take x common. So the moment you take x common, 3y minus 1 is equals to 5y plus 1. Okay. And the value of x from here is 5y plus 1 upon 3y minus 1. Can you see that you are again in the same situation over here? See here, can you see this? You saw that denominator cannot be 0. So that's why x cannot be 5 by 3. Here again you have to do the same thing. Again denominator cannot be 0. So 3y minus 1 not equals to 0. So y cannot be equals to 1 by 3. So range over here finally will be all real values. Y belongs to all real values except 1 by 3. How many of you got this? How many of you got this? Everybody? Understanding it? Okay. Shall I give you another question? Are we next question ready? Are we next question ready? So yes, f of x is equals to 2x minus 5 upon 3x plus 4. Chalo, let's see how many of you are able to answer this. Domain, so everybody is telling me, na, tell me range. I'm waiting for the range. Ronit, no. Domain, I know. Domain is easy. Tell me the range. By the way, I have a ninja technique. Ninja technique coming. Okay. And by the way, this technique is not there in Roar series also. In 2024, 2026, you are going to get a lot of ninja techniques which 2025 aspirants also did not get. So domain is quite clear. If I calculate domain, it is very easy. For domain, just make denominator not equals to 3x plus 4 not equals to 0. X not equals to minus 4 by 3. All real values except minus 4 by 3. X belongs to. Okay, MD Satish, I'll do that. Noted, noted. I think Rohit, you got it right. So range is nothing but. So how do you calculate range? By the way, y is equals to 2x minus 5 upon 3x plus 4. Step by step. Cross multiply. 3xy plus 4y is equals to 2x minus 5. Okay. Now I'll keep the terms related to x together. So x, if I take common, 3y minus 2. And this is going to be minus 4y minus 5. So x is nothing but minus of 4y minus 5 upon 3y minus 2. Now again, denominator can never be 0. So this thing, okay, so this is going to give you 3y minus 2 not equals to 0. Y not equals to 2 by 3. So range, everybody, is y belongs to all real values except 2 by 3. Okay, all right. Now I have a ninja technique. Okay. So this is the normal method. Okay. So this is normal method. Now I have a ninja technique. Are we ready for it? Huh? Ninja technique to calculate range. Ninja technique to calculate range. Okay. Correct. So, and you know what? This is also you guys also can tell me. This is an observation. Okay. So this is specially for linear by linear, by the way. Especially for linear by linear, all range will be all real values except that one value, which value will be 2 by 3. That is coefficient of x in numerator upon coefficient of x in denominator. So this is, can you see directly you can find, na, 2 by 3. No need to do all this. Now if I go back and if I check that is it applicable in every question, let us check ninja technique. So now range will be what? All real values except 5 by 3. Okay. Now can you see the range of this will be y belongs to all real values except 1 by 3, my dear students. Is it working for you? Good, good, good. Yes. Okay. So now if you have got it, just tell me. Tell me one thing. F of x is equals to 3x minus 1 upon 2x minus 5. Just tell me the domain and range. Calculation of domain is already very easy. X belongs to R minus 5 by 2. Just the denominator will not be equals to 0. Okay. And range will be y belongs to R minus 3 by 2. Coefficient of x in numerator upon coefficient of x in denominator. So no need to do that cross multiplication and so on. Yes? Hannah? Okay, so this small little techniques we are going to learn along the way in the sessions. Okay? Alright, now let's talk about another function which is an exponential function. Okay? Exponential function is y is equals to a raised to power x, where a is greater than 0. Where a is greater than 0. Okay? So this can be y is equals to 2 power x. If I talk about domain of such function, right, y is equals to 2 power x or y is equals to e power x or y is equals to half power x. Okay, so in that case, domain will be x belongs to all real values, and you have to remember range of any exponential function is all positive values. That's it. No zero. Nothing. No zero, no negative. All positive values. Okay, all right. Now the graph of exponential function where your this constant 2 power x, e power x. So 2 and e both are greater than 1. So the graph will be looking like this. The graph will be looking like this. And where a is between 0 to 1. Between 0 to 1. Okay. So the graph will be like this. And a cannot be negative, right? A can be either, a can only be positive. So now two cases, if a is a fraction, for example, half power x, graph of half power x and graph of 2 power x. Okay. All right. Yes. Now let us understand how are we plotting the graph. So what I'll be doing is x and y. Okay, suppose if I put x is equals to 0, suppose you take y is equals to 2 power x. This is your function. Now put x is equals to 0. 2 power 0 is 1. 2 power 0 is 1. Okay. Alright. Clear? Now x infinity. X infinity if you put 2 power infinity will be infinity. Okay. If you put x is equals to 1, you will get 2 power 1. If you put x is equals to minus infinity, now look at this very carefully. 2 power minus infinity. See, 2 power minus infinity is 1 upon 2 power infinity. And 2 power infinity is nothing but positive infinity, which is tending towards 0. That means 2 power minus infinity becomes 0. How many of you have understood this? Now, if you understand this and try to plot this graph, first of all, 0, 1. X is equals to 0, y is equals to 1. This is the point, 0, 1. X is equals to 1, y will be equals to 2. So this is, suppose x is equals to 1, this is y is equals to 1, 2. X is equals to infinity, y is equals to infinity. That means the graph will go like this exponentially. X minus infinity, y 0. So the moment you put x is equals to minus infinity, your graph will touch x-axis towards 0. Okay? Everybody? How many of you are getting it? Huh? Now same thing you can do half power y is equals to 1 by 2 power x. So y is equals to 2 power minus x. Try to draw this graph. Again it will have 0, 1 as common point. Okay, and so on. So the graph will look like this. Okay. So domain is what? X belongs to all real and range is only positive values. Now here are the two questions which we are going to do. We need to calculate. We need to calculate first of all domain of e raised to power 2x. Okay. So let's talk about domain. E power 2x. So x, though you can put anything. So domain is x belongs to R over here as well. E power x plus 1. Again domain will be what? X belongs to R. Now let's talk about range. Okay. So e power 2x. See, with the graph itself, it is quite visible that your range is only positive values because there is no graph below x-axis. Can you see any graph below x-axis? No. The graph is not even touching the x-axis. It is always above the x-axis. So that is why the range is only positive values for any exponential function, by the way. So again, e power 2x. So can you see that 2x? See, if x belongs to all real values, then 2x will also belongs to all real values. That means e power you will put minus infinity to plus infinity, and in the output you are going to get all positive values. So this is y belongs to again 0 to infinity. Another way of representing is y belongs to r plus. Okay, either this or this. Okay, now just tell me one thing. See, I told you, no, e power x is belonging to 0 to infinity. Yes or no? E power x, है ना? Range is what? 0 to infinity. Y belongs to 0 to infinity. Now e power x plus 1. So e power x plus 1 belongs to 0 plus 1 is 1 and infinity plus 1 becomes infinity. So this, in this case, e power x plus 1 is belonging to 1 to infinity. So range over here is y belongs to 1 to infinity. This is another way of calculating range. How to calculate range? How to calculate range? So this is, see, calculation of range is very tricky thing. You will get a lot of methods based on different function. Calculation of domain is the same thing, almost similar in every question. But calculation of domain, calculation of range, if you go and check my videos also, previous year videos also, if you go and check, you will realize that Ninja Ma'am always, whenever there is a new question, Ninja Ma'am always apply another technique to find the range. Because see, what did Ninja Ma'am do to find the range? She said e power x is this, e power x plus 1 will be this. This is one technique to calculate range. Now Ninja Ma'am gave another technique to calculate range. This is one of the technique. The next technique was what? The very first technique, just cross multiply and do this. See, there are multiple techniques. So you have to make your notes that if at all linear by linear is coming, then this is how we need to calculate the range. There is no one technique. Okay. Okay. Thank you, Kaustubh, for your kind words. But yes, I am working very hard in front of this screen. Now I want you all to work very hard, harder than me, okay? All right. Chalo. Okay, now let's talk about the next function, which is logarithmic function. Okay, logarithmic function. Ready, ready, ready? Although I need to take a complete session on logarithm, like full-fledged session will be there, okay, in upcoming days. Make sure you attend that. Okay, if I attend your regular classes, can I crack JEE 2026? Vanita, see, the only problem with students who are not able to crack JEE is what? Tell me. Achha, everybody keep guessing, huh? What do you think that, what is that one thing JEE aspirants are not able to do and that they are not able to crack JEE? What do you think? You should be aware, by the way, that okay, you are getting into JEE, you are about to give JEE exam, right? Periodic function will be the last topic, by the way, Vaibhav. After everything is done, periodic will be the last thing we are going to discuss. Okay, now logarithmic function. Logarithmic function is y is equals to log x to the base a. The very interesting thing about logarithmic function is that the domain and range will be the interchange of exponential function. Remember, in exponential function, what was the domain, ma'am? All real values. So here range is all real values. In exponential function, what was the range, by the way? Ma'am, all positive values. Here, domain is all positive values, right? Okay. So whenever you see a log of x, okay, whenever you see log of x, acha, you are giving me answers. Spidey's brain rot, consistency, yes, definitely. Lack of practice, clarity on concept in, I think, see, mostly clarity of concept you will definitely get if you are consistent and you are with right mentorship. If you are watching right lectures, okay, watching or you are attending. So if at all, see, what we do is the right coaching we have selected or right YouTube channel we are at, but eventually 1 month we are on time, on regular, second month onwards we struggle with attending the lectures because the syllabus is vast, na? Imagine same job you have to do it approximately 10 to 11 months. Okay, if you are a 1-year aspirant, same job daily. It's not an easy task in this particular era. Okay. All right. So yes, domain of log function is all positive values, that is x should be greater than 0. And range is minus infinity to infinity. The graph of logarithmic function looks like this. And you know what? This is half. This is nothing but that bouquet. Have you seen that bouquet? Flower bouquet. Okay, flower bouquet. Can you see the half bouquet? So this is your log of x to the base e or x to the base 2, where base is greater than 1. Here y is equals to log of x to the base half. So here base is between 0 and 1. Okay, how to plot this curve? So you can clearly see that this is 1, 0 here. This is also 1, 0. I think slight idea to you have na logarithm ka. Log 1 is 0. Okay. See. So now domain and range you already have. So now this is the question. Find the domain and range of log x minus 2. First of all, domain. So we know the domain of log. The input of log should always be positive. So here for domain, x minus 2 greater than 0. That means x greater than 2. X belongs to 2 to infinity. Yes, Abhijit, you can attend this session, by the way, huh? This session, class 9 student can also attend. By the way, Abhijit is in 9th grade and I have a story to share. Okay, so domain is right there. Now, meanwhile, you guys are doing some effort to calculate range. I need some story to tell, okay? So, and the story is because I'm sharing it right here because I saw Abhijit, because he is claiming that he is in 9th grade. Okay. So, once upon a time in 2016, when I was teaching in Bansal classes Kota, okay, so there was a student who was in class 9th, by the way, okay, who was in class 9th, and he used to sit in class 11th, okay, he used to sit in class 11th. He used to attend all the lectures of class 11th, not only lectures, I'm talking about the offline classes. He used to give test of offline lectures also, like the complete batch. So we have a regular test also. So he used to give test also. And your mind will be blown that in every test, from the beginning to the very end of that batch, he was rank 1 student in that batch. Okay. So class 11 student, nobody was used to get first rank. Only that 9th grade student used to get one first rank in that classes, and eventually he gave IIT JEE mains, he cleared it, JEE advance also, and approximately he got all India rank 56 in JEE advance, 56 or 54. Okay, so I mean anything can happen. Class 9th, do not underestimate, because Abhijit always asks me, ma'am, can I get all India rank 1? I am in class 9th. Every time he is asking and I am ignoring. And right now I thought, okay, I need to address this. Let me tell him that yes, definitely all India rank though you can get. And obviously there is an advantage if you start early. Okay. Chalo. But I just don't recommend that start whenever you are in class 7th. No. I mean, you can obviously study higher level classes if you are in class 7th. No. 9th, 10th is something you can start touching that class 11th, 12th topics a little bit. Okay. Alright. Chalo. Domain is here. Nobody gave me range. Nobody gave me range. Nobody gave me range. So range, how to calculate range? Okay. So just tell me one thing. See, I think that range of, so log of 0 to infinity. See, what domain is 0 to infinity, right? So if in input you will put 0 to infinity, in output you will get minus infinity to infinity. Yes or no? See, understand now. If log, inside the log you are putting r plus, that means 0 to infinity. So you are going to get minus infinity to infinity. Did you understand this logic? So now x minus 2, just tell me, x minus 2 is also 0 to infinity. X minus 2 is greater than 0, that means x minus, so again log of x minus 2, this x minus 2 value is nothing but 0 to infinity. So log of 0 to infinity eventually will give you minus infinity to infinity. This is the output. So that means range over here means x belongs to all real values. Okay. Chalo. Let's do one thing. Let's do a question on domain. Let's see how many of you are able to answer this. Okay. And trust me, I have started this and I'm loving it already. Okay. Two minutes to go. In the chat box, I can see Vignesh is saying option C. Shakti is saying option 4. What about others? Subhash is saying option B. What about others? Okay, B, C, every option you have given, huh? Which option? Only A option is left. Last 20 seconds, you have still time to correct. All right, all right. Okay, let's see. So, by the way, there is this thing which I have to tell you. Suppose your function is comprising of f1 plus f2 or f1 minus f2. That means sum of two functions you can clearly see. Sum of two functions or difference of two functions or product of two functions, right? Multiplication, division, okay, anything. Suppose this is the case, then you have to calculate two domain number 1. Domain number 1, okay? So domain number 1, I told you, na, denominator cannot be 0. So this is your first thing. Calculate domain number 1. So denominator can never be 0. So 4 minus x square not equals to 0. 4 minus x square not equals to 0. Everybody? So x square not equals to 4. X can never be equal to plus minus 2. So domain number 1 means what? X belongs to all real values except plus minus 2. So plus and minus 2 will not be in my answer. By the way, am I able to eliminate the answers? No, I think plus 2 and minus 2, none of the options is having plus 2 and minus 2. So with this particular case, so I am not able to answer it. Now, Ninja Ma'am told us so this is your D2. Ninja Ma'am told us whenever you see log, anything which is inside the logarithm should always be positive. Yes or no? Okay. Log of x cube minus x. So D2. D2 says anything inside of log should always be positive. How many of you know wavy curve method? Wavy curve method, okay? Yes, Abhijit is going to tell you the importance of wavy curve, huh? Because he was there in that lecture. And Abhijit, look also, class 12th, the very first session, without wavy curve, you won't be able to solve questions, right? Now take x common. So this is x square minus 1 greater than 0. X plus 1, x minus 1, factorize. Okay, now plot on the number line. So this is 0, minus 1, 1, plus, minus, plus, minus. You are looking for greater than 0, you are looking for positive. That means 1 to infinity, minus 1 to 0, and that's it. So finally D2 will be what? X belongs to minus 1 comma 0 union 1 to infinity. Okay, but can you see this is your D2? But eventually this is D2, this is D1, correct? Now finally what you need to do is you need D1 intersection D2. This will be your final domain. Final domain. Final domain is D1 intersection D2, my dear students. D1 intersection D2. X belongs to minus 1 to 0 and 1 to infinity. Now please be careful. 1 to infinity means 2 is included, right? Can you see that 2 is right here in this interval? And domain number 1 is saying no, x is equals to 2 is not even allowed. So 1 to infinity may say you have to remove just 2. So this is going to be minus 1 to 0 union. Now 1 to infinity will be 1 to 2 union 2 to infinity. Okay, can you see? So minus 1 to 0, then 1 to 2, and then 2 to, so this is wrong. Can you see option C is absolutely correct? This is also wrong. This is also wrong. No, Rohanit, I know you weren't there, but I was like, Abhijit should know because he's in class 9th. So when I teach class 11 student and I teach wavy curve, they ask me, is there a question from wavy curve? Is there a question from wavy curve in JEE Main or JEE Advanced? I say no. Then you're like, I won't study. Then I'm like, don't study, but how will you do these type of problems? You won't be able to solve any question if you don't know wavy curve method. So I'm trying to emphasize on that importance. Yes. Kochi is saying there is only one lecture in Roar series, but you haven't took that, ma'am. See, because I'm not able to pronounce your name, but I have taken relations and functions as a complete chapter for JEE Main. I have not segregated 11th or 12th. In JEE Main, they don't say that, okay, relation class 11th, relation class 12th. So JEE Main perspective say, I have covered 11th plus 12th in the same video. Go and watch. Okay. Alrighty. Let's talk about modulus function now. Are we ready for the modulus function? We'll solve so many questions on domain. Okay. So modulus function. Modulus function means y is equals to mod x. So now y is equals to mod x is a modulus function. Remember mod is absolute value. So just tell me mod of 3 is 3. But mod of minus 3 will be what? That is also 3. Okay. Now understand that how shall we explain or define this function algebraically. So mod x is going to give you x when your x is positive. So this is, I think, very easy. Suppose you have mod of 3, you will just write 3. Because your 3 is a positive number, no? So for a positive number, taking mod is very direct. So mod x will be just x if your x is positive, but mod x becomes minus x if your x becomes negative. Now you'll be like, hold on, ma'am. Okay, this thing though we have understood that if my x is positive, for example, mod 3 is equals to 3. But you are saying mod of minus 3, if there is a negative number, then you will get minus x. That means, are you saying mod x is minus x? But mod means what we have studied as mod is always positive. So mod x is equals to minus x. How come? Mod x is equals to minus x. You are saying mod is giving negative value. Ma'am, we are not understanding. What to do now? See, understand. Minus x is actually a positive quantity. Minus x is not a negative quantity. But ma'am, negative sign. Array, you are seeing negative sign, but x itself is a negative sign. So if x is negative, suppose x is minus 3, just tell me if you put minus 3 in place of x. So minus is already there and x will be minus 3, 2 minus you can see. So it will become positive now. Okay. Got it? Yes, everybody? Okay, so this is your now modulus function. So y is equals to modulus x. Now the domain will be x belongs to all real. That means you can put any real x in place of x. But output, that is range. Now mod value will never give you negative value. It can give you 0, it can give you positive, but never a negative value. So 0 to infinity, can you see that r plus all positive values and 0. You can also write it as y belongs to 0 to infinity. This is also one way. This is the graph. You can see. So graph, how will you plot it? First of all, y is equals to x when x is positive. So x positive, y is equals to x. This is y is equals to x line. X negative, y is equals to minus x. Okay. Okay, all right. Yes. Chalo, let's Do one question based on modulus. Let's see how many of you are able to do that. First of all, domain. So for domain, it is so obvious that denominator can never be 0. So for domain, your mod of x, right? So x can never be 0. So domain ke liye, tell me, x belongs to all real except 0. Now for range, let's talk about range. Can anybody tell me what is the value of square root of x square? Square root of x square. Square root of x square. What is the value of square root of x square? Okay, so square root of x square is mod x. Huh? Keep this in mind. Very, very important. So this is mod x upon mod x, which is nothing but 1. So fx is equals to 1. So range over here is y belongs to, or y is equals to 1. That's it. No, no Marutram, range is 1 comma minus 1. No. Rohanit, wrong answer, Rohanit. Anonymous to saying range 0 to infinity. I am not teaching. Cancel. Return. Amazon return. Let's do it. Rohanit, wrong. This is absolutely wrong. Please don't do that. Square root of x square is equals to plus minus x is absolutely wrong. Please don't do this. This is sin. Sin, sin, sin. Output of square root can never be negative. Output of square root can never ever be negative. Okay? Everybody getting it? All right, let's see the next question. How many of you are able to do that? Okay. Ma'am, but minus x when squared becomes positive, na? Yes, it becomes positive. Then, so it will be positive only, na? You are saying plus minus x. Where is this negative thing coming from? Yes, Ibu, trigonometry on Monday. Monday will start trigonometry, okay? This question, anybody? Are you on it? Let me just give you the options. Huh? This is... see, square root, okay? So, first of all, we cannot Square root of any expression, if at all this type of thing is given, that means the expression should always be what? Greater than or equals to 0. Okay, so whenever you see square root, what you have to do is that expression should always be either 0 or positive. Okay, expression should always be, but if your square root is in denominator, then what will you do? Your expression will only be positive, because expression, if it is becoming 0, the denominator cannot be 0. So right now I think this is the case, correct or not? So now square root is in denominator, so expression inside square root is strictly positive. It can never be 0 also. Okay, can never be 0. Mod x minus x greater than 0. Now just think about it now. Just tell me. So mod x greater than x. Now think about it. Suppose x is, so you have 3 options, right? You have 3 options. X ke liye, for x you have 3 options. First one is x is equals to 0, x negative and x positive. Put x is equals to 0 and check. Is it working for you? Is this inequality working? So ma'am, if you put x is equals to 0, so mod 0 is 0. So it will become mod 0 greater than 0. So 0 greater than 0 is a false thing. That means x is equals to 0 will not be there in my answer. Okay ma'am, got it. So 0 will never ever be there. Okay. Now let's talk about negative. If x is negative, then what will happen? So if x is negative, pick any negative number now. Pick minus 1. So if you take minus 1, it will become what? Mod of minus 1. So mod minus 1 is greater than minus 1. Is it true? Mod minus 1 is 1 greater than minus 1. Arey, it is true. See, if x is negative, see, this is always positive. Mod value will always be positive. X is negative, now this x will be negative. Now you tell me, positive greater than negative. Positive greater than negative. Positive greater than negative, this is obviously true, na? Positive number will always be greater. That means negative values of x will be acceptable. Okay, so negative. Now if x is positive, then tell me. So ma'am, if x is positive, put x is equals to 3, mod 3 greater than 3. This is the 3 greater than 3. So this is not possible. False. 3 greater than 3 is false statement. That means positive values are not satisfying. So if you put positive value, put x is equals to 3, not happening. X is equals to 2, not happening. Positive values will not be there, only negative values. 0 also is not getting satisfied. So D option is wrong. Minus infinity to 0 is correct. So I think option, this is also wrong. So whatever minus infinity to 0. So now domain will be what? X belongs to minus infinity to 0, or you can say x belongs to all negative values of x. Yes, Rohanit, you are absolutely correct, huh? Chalo, one homework question. One homework question I would like to give you. One homework question. F of x is equals to square root of x square minus 5x plus 6. Okay, Abhijit, this is for you also. So, find the domain and let me know your answers in the chat box. In the next session, what are we going to do? In the next session, what are we going to do? We are going to talk about greatest integer function, fractional part, and we are going to do all the questions related to domain of a function. Okay, some JEE main questions also we are going to do in the next session, because JEE main ask a lot of questions from, especially from domain of a function. Okay, so here comes the ending of this session. This is me, your Ninja Ma'am, signing off.